Hey guys, how's it going? In this video, I'm going to walk through this Leetcode 21 merge to sorted list. This problem was asked by Amazon for 36 times in the past 6 months. Let's dive in. So we need to merge two sorted linked list and return it as one sorted list. Let's look at an example in here. One list we are given is 1, 2, and 4. Another one is 1, 3, and 4. So we need to return only one and only one sorted list, which is 1, 1, 2, 3, 4, 4. Okay, so that's one example. And also we have another two edge cases. If two of the list are empty, so we will return an empty list. Another one is if one of them is empty, another one has only one node, we just return that one node. Okay, and there's some constraint. We have the number of nodes should be between 0 and 50. Also the value between -100 and 100, and also both of the two lists are sorted in non-decreasing order. So this is very important. Okay, let's look at one more example. Let me zoom in a little bit. If we have one list, looks like this: 1 to 6. Another one is 3 to 4 and 5. Okay, so both of them are non-decreasing. Okay, and also they are not the same length. Okay, and we need to grab each time when we loop to the node, we have to grab the smaller node. So for example, when we grab the head, the first one is 1, another one is 3. So 1 versus 3, smaller one is 3. Smaller one is 1. Okay, and then we can put this one aside because we have already dealt with it. So next one will be still 3 because we haven't not yet worked with it. 3 from the first comparison, right? 3 and another one is 6. Okay, which is the second node of the first list because the first node we have already worked on. So 3 versus 6, the smaller one is 3. So and then we concatenate that with the 1. Okay, so now it's 1 and 3. Okay, so now the 3 is aside and the 1 is aside. Also now we have a 6 and 4. So we compare the 6 with the 4. Okay, smaller one is 4. Okay, so we can put that aside. And now the last one, our last pair will be 6 with the 5. Okay, the smaller one with 5. So what's remaining is 6, and then we appended the 6 at the end. So the end product for this particular exercise is a 1, 3, 4, 5, and 6. So we need to have a function is to grab the smaller node of the two nodes we compare at each time. Okay, and yeah, so this is actually the function. I'm gonna walk through with you later, and let me show you the biggest picture. So first, let me zoom out a little bit. First, we have to discuss some edge cases, right? If L1 is known, and we just return the other one. Same for L2, right? If both of them is none, just return a none. So this is some edge cases to cover. Now we have the dummy head. Actually, dummy head is pointed to the next of the dummy head points to the one that we're going to return at the end. Okay, so we just return dummy head next. Okay. I set the value as -1 in here. Probably this is not the best to do because the node value is between -100 to 100. So probably I should set this one to -101 on the safe side. Okay. So I have the current node, and actually now initially it's just the dummy head. Okay, and now I have the current 1 and current 2. This points to the linked, the first linked list and the second linked list, while both of them is not none. Okay, and now we're grabbing the smaller node. Remember in our first comparison, we're always grabbing the smaller one, right? So the smaller node comes from this function that I'm going to show you. Actually, you have already seen it, but I'm going to go through it later to compare the current 1 and the current 2. Okay, we grab the smaller one, and the current dot next. This is where we build a connection, right? Current dot next equals to the smaller node, and the current one actually initially is at the dummy head. And now we build the first connection, the current dot next, grabbing the smaller of the current one and current two, and then we move the current to the next one, right? Move it along. Okay. So now let's look at what's going on with the grab smaller. As you probably get, as the name suggests, just grabbing the smaller of the two. But look at the implementation. If a dot value is smaller than b dot value, we just grab the a. Otherwise, we grab b. Okay, as simple as that. Okay, let's move on. So if the current one is the smaller one that being grabbed, and then we have already dealt with that, and then we move it along to the next node. Okay, so current one dot equal to current one dot next. On the flip side, we just move the current two dot next, right? So basically whichever we grabbed among the two, we just move it to the next one because we have already dealt with it. Just we have to move, and so we're gonna move along in that list. So when we get out from this while loop, maybe in the case where current one is not completely done, or current two is not completely done, right? Because in this while loop, both of them has content. We can keep this while loop going. However, if one of the nodes still have node, one of the linked list still have node, we just append it directly to the current dot next. Okay, as simple as that. And at the end, we just return the dummy head, which we declare at the beginning, dot next. Okay, so let's look at the result. See, pretty efficient. For time complexity, it's going to be big O of n plus m. So n being the length of the first linked list, m being the length of the second linked list. Because we are traversing both of linked list at the same time. In the worst case, we have to traverse each one of the nodes of both the linked list. So it's n, big O of n plus m. For space complexity, it's going to be O, because we just have some dummy nodes here and there. For example, dummy nodes, some current nodes, so it's big O1, it's not scaled. So this is my solution to this problem. I hope you find this helpful. If it is, please like and subscribe. Thank you so much for watching. We'll see you in the next one.